Okay. So you said to start S block element, isn't it?
Yes, sir.
S block element. What are S block element? Can you guess me? Can you guess S block element? Try to guess what are S block element.
Yes, sir.
What are S block element, Janab? S block element.
Metals.
Yeah, S block elements are metal. Very good. Okay. Definition, if you talk about elements in which they are talking about elements in which, okay, elements in which last electron, they are talking about elements in which last electrons, okay, enters into what, student? S orbital. The elements in which
Yes,
last
sir.
electron enters into S orbital are known as what? That is, are known as S block element, are known as S block elements, right? So here elements in which last electron enters into S orbital are known as S block element. Now let us try to understand example. If you talk about example, Janab, so what are the example? If you see, that is a lithium. Lithium is the 3. Can you do the configuration of lithium? 2 and 1, 2 comma 1, right? 2 comma 1, that is okay, but orbital configuration what will be there? 1s2, then comma, that is going to be 2s1. Will you be able to understand this? So last electron, if you see, last electron entering into which orbital? That is s orbital. Yes or no?
Yes, sir.
If you talk about beryllium, so beryllium, if you see beryllium, so beryllium atomic number 4 and configuration 2 comma 2. If you do the configuration, this is 1s2, then it is going to be 2s2. So last electron entering into where? That is s orbital. S orbital.
Yes, sir.
So yes, if you go for the sodium, sodium is 11. 11 means what? 2 comma 8 comma 1. See, 1s2, then it is going to be 2s2, then here is 2p6, then it is going to be 3s1. 2, 2, 4, 6,
Yes, sir.
11. So again going to be what? This is the s orbital. Here if you are going for the magnesium, magnesium is 12. Here is configuration 2 comma 8 comma 2. So here is 1s2, then here is 2s2, 2p6, then it is going to be 3s2. So you will find that is again last electron entering into s orbital. So these are known as what? S block element. Will you be able to understand?
Yes, sir.
Okay. So will you write the note also?
Yes.
Okay. Then make a note, please, so that we will go for the classifications.
Yes, sir.
Done?
Wait, sir.
Done?
No, yes, sir. Done.
Okay. Now, classification of S block element. We are going for the next point, that is classification of S block element. That is classification of S block element. Classification of S block element. So
Yes, sir.
how S block elements are classified? They are classified into two categories. Okay. So what are these two categories? That is yes, group one element. Group one element. S block elements are classified in two categories: group one element, and second one is group two element. Group two element. Right. If you talk about group one element, so that is what is. If you talk about group one element, they are known as alkali metal. ALKALI, alkali metals. And if you see group two element, that is called alkaline earth metal. This is going to be alkaline earth metal, right? Alkaline earth metals, right? Alkaline earth metals. So if you talk about alkali metal, Janab, that is they are the known as group one metal, alkali metal, and another is that is group two, or that is what is known as alkaline earth metal. Now you see what are these alkali metal. If you see these alkali metal, the configuration is what is their valence cell configuration. Valence cell configuration. What is going to come valence cell configuration? Here it will be that is NS1, this one. And here is what is going to be valence cell configuration. If you talk about valence cell configuration, it is going to be NS2. Okay, they are the basic difference, NS1, NS2. Of example we are writing. What are example? Lithium, sodium, potassium, rubidium, cesium, francium. Here is what are the example if you are talking about beryllium, magnesium, calcium, strontium, barium, and radium. Okay, let's try to understand. Here is what is there: 3, 11, 19, 37, 55, 87. If you are talking about this one, 4, 12, 20, 38, 56, and 88. Now do the configuration. If you are doing the configuration, it is the 1s2, comma 2s1. So you can see the balance cell configuration is what is there, s1, right? Here you see what are there. This is the 1s2, and here going to be 2s2. So balance cell configuration is how much is there, 2s2. Now go for the sodium. Here is what is there, 1s2, then 2s2, 2p6, 3s1. So 2 to 4, 6, 10, 11, 3s1, right? Here you can go this one, 1s2, 2s2, 2p6, then it is going to be what, 3s2. This is, so here is you can see they are equal to ns2, so s2, and they are equal to s1. If you are talking about potassium, so potassium will come here is 4s1, this way, 4s1. If you are talking about rubidium, it is going to be how much, 5s1. If you are talking about cesium, cesium is going to be 6s1. And that is next one. If you see what one, francium, francium is going to be 7s1. So all you see what are coming, that is all is coming s1, s1, s1. So they all are the alkali metal. If you talk about the calcium, calcium is coming 4s2. If you are doing strontium, this is going to be 5s2. Barium, barium is 6s2. And radium, radium is what is going to be 7s2. So they are the valence cell configuration. So S block element are classified into two categories, group 1 and group 2. Group 1 is known as what, alkali metal, and group 2 is known as alkaline earth metal. Group 1 is electronic configuration is ns1, group 2 electronic configuration is ns2. Example of group 1 is lithium, sodium, potassium, rubidium, cesium, francium, and group 2 configuration is beryllium, magnesium, calcium, strontium, barium, radium. Can you be able to understand this, Janab?
Yes, sir.
Okay, can you write down this one?
Yes.
Please write down.
Done, sir.
Okay, thank you. So now we are going to understand some properties. Slowly we are going to understand. Let us try to understand. Okay. So study of, we are going to put the heading study of going group 1 element. Okay. Group 1 element. So first of all, we are studying all the properties of group 1 element, then group 2 element. Study of group 1 element, that is what is called alkali metal. Here is what? Alkali metals. Okay, this is what we are having the property. Up now, what are the first one? Atomic radii. If you talk about the first one, we are going to study atomic radii. So they are talking about on moving down the group, on moving down the group, on moving down the group, no, number of cell. They are saying on moving down the group, number of cell increases, number of cell increases, number of cell increases, and hence what is going to be, and hence distance between, they are talking about, and hence distance between, B by W means between nucleus and outermost electron, nucleus and outermost electron also increases, okay, nucleus and outermost electron also increases. So atomic radii, what is going to happen? So atomic radii increases. This is what the point. So atomic radii increases. How can you be able to understand? See here. Next page better I'm explaining. Next one. See, if I'm talking about lithium, then sodium. Okay, little bit, let us put out the space here so it will be better. Lithium on top, then it is going to be sodium. Here is potassium, rubidium, cesium, and last one it is going to be francium. So here configuration is how much it is going to be. Asa, here is the if configuration is 2,1. Here that is sodium is what is there? Sodium hai. Here is 2,8,1. Here is 19. है ना? 2,8,8,1. Here is the 37 is there na? 2,8,8,18, no, 2, 8, 8, 18, 1. This will be there. Now 37, if you are going 55, so here is it is going to be 2,8,8, 18, 18, and 1. Here is the francium. Francium, if you are going 87, so it is going to be 2,8,8, 18, 18, 32, 1. These are there. Now see number of cell you see. So this number is K. This is the L. Here is going to be K. This is L and N. Here is O, K, L, M, N. Okay, what is there? K. It is going to be L. This is going K, L. This is going to be M. Here is M, N, O. Right? If you talk about K, this is L, M, N,
Yes, sir.
O, P. Here you can see K, this is L, this is M, N, O, P, Q. See, number of cell, how many are there? 2 cell. Yes or no? 2 cell. Here is how many are there? 3 cell. Here how many are there? This is going to be 4 cell. How many are there? 5 cell. Okay, how many are there? 6 cell. Yes or no? Here is how many are there? 7 cell. 3, 7. So let us try. So lithium, if you are making the size, so 2 cell I am making here. So it is the 2 cell. Yes, yeah, no. Then you are going to give the sodium. Sodium is going to be 3 cell. How it will be? That is the 1. Here is going to be the 2. This is going to be the 3. Okay, size increasing or decreasing? What is happening to the size? Then up see the size. Are they are increasing? Distance between nucleus and outermost
Yes,
electron.
sir. Increasing.
Okay, thank you. So that is if you are making rubidium. So size of rubidium is also going to increase only. Okay. So what is happening? That is the if we are writing number of cell down the group, if you are going, number of cell are getting increased. Since the number of cell getting increased, so size or what is happening? Size increases. Are you be able to understand? Yes, yeah, no.
Yes, sir.
Okay. Can you make a note of it? Here, the size order of atomic size means lithium, then sodium, then potassium, then rubidium, then cesium, and last one is francium. So what is happening? Size increases. Kindly make a note, please. Done.
Yeah, sir, done.
Okay, next page, little bit there. One diagram is there that you please draw now. This one. So that trend will be helpful for other properties.
Okay, sir.
Hmm. Done. Done.
Done, sir.
Okay. So we are going for study the next property, ionization energy. IONISATION, ionization energy. Okay. This is also known as IE. What is ionization energy? Do you remember I told you in the periodic properties, I teach you in the periodic properties? Any point do you remember? Janab, any point do you remember? Tell me.
Yes, sir.
Tell me, what is ionization energy?
Wait, sir. Sir, ionization energy. Wait, sir. I know. It is the energy that electron in a gaseous atom and atom that absorbs
Yeah.
the freely moving electrons.
Okay, good. See, the amount of energy required to remove an outermost electron from an isolated gaseous atom, no? From an isolated gaseous atom, right? So see, the amount of energy required to remove an outermost electron from an isolated gaseous atom. See, no star. See the what is this? Small size, right? Equal to, yeah, small size proportional. That is small size proportional. What? Strong force of attraction. Strong force of attraction. Okay, strong force of attraction. Proportional. More energy required. More energy required. More energy required to remove electron. More energy required to remove electron. Okay. So more 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 ionization energy. Star number 2. Okay. Large size. If the size is what is Janab, the large size proportional to weak force of attraction. Weak force of attraction between nucleus and outermost electron. Weak force of attraction. So weak force of attraction, Janab. So that is less energy required. Less energy required to remove electron. Less energy required to remove electron.
Yes, sir.
So less energy required. So less IE. Less IE. So Janab, if I will ask you, see what is happening, top to bottom if you are going now. So see,
Yes, sir.
lithium, sodium, potassium, rubidium, cesium. Size, what is happening, Janab? Size increasing, yes or no? Asa, too much sound coming here. Size increases. Okay. This is
Yes,
what
sir.
is size increases, Janab. So force, what will be there? If more distance is there, so force will be decreases now. Force decreases. Force decreases. So if Janab force decreases, so that is less energy required, yes or no? Less energy required. Less energy required. अब Janab less energy required, it means IA will be more or less. IE will be more or less. IE will be more or less.
Yes, sir.
Less.
Less.
Understood this one?
Yes,
Understood?
sir. Understood.
Okay. See, write down that.
Yes, sir. Right.
Mhm. 840. 840. Done, Janab? Hello?
Yeah, sir. Last part.
Okay.
Done, sir.
Okay, next page also they are little bit Janab. Okay, where I wrote the order. Today I will go to marriage party, so I will stop by 8:30. Na, so don't mind. Yes,
Yes,
ma'am.
sir, sure.
So I need to go in the marriage of my relative.
Okay, sir. Okay.
Hmm.
Wait,
So,
sir. Almost done.
no issue. Done. Done, Janab.
Yes, sir. Done.
Okay, so we'll study in the next day, na?
Okay, sir. Sure.
Okay, bye, bye.